Welcome back, everybody, to HardHat Uncovered. We're coming to you from the HardHat Uncovered Studios in Alexandria, Virginia. Welcome back, Lieutenant Oates.
Thanks. I'm glad to be back.
Welcome back, Mr. Hipple.
What's going on, fellas?
Okay, so this is part 2 to our silica. I was going to say silicosis series, to our silica series. And if you haven't listened into part 1, be sure you tuned in because we talked about just the basics of it. You know, what is silica? Where can it be found? The new rule when it comes to OSHA, some of the standards and where you can find it at when it comes to ISO and the OSHA general industry and the construction industry. So we made it through the medical surveillance program that is required by OSHA, and we were just about to get into the weeds here for the OSHA Table 1 that has been rolled out. So
yeah, I know we left you guys right on the edge of your seats
I'm
with
telling
some
you,
seriously cool, riveting information.
I guarantee there's some people out there missing some nails now. They done chewed them all off waiting.
Yeah.
All right, Dylan, why don't you take it away with the Table 1?
Okay, guys. So first thing we're going to do is we're going to talk about the different options when it comes to protecting ourselves and our workers. So the easiest way to comply with the new OSHA silica requirements is OSHA's Table 1. So what OSHA Table 1 is, it basically lists 18 common construction activities and gives you a guideline on how to be in compliance with OSHA and gives you a guideline on how to reduce your workers' exposure to silica. So it mainly uses two methods, a wet method and a vacuum method, but it's a great tool to use. I've used it on multiple occasions. Construction sites that I've been a part of, it's been the easiest way to comply. So some of the examples on OSHA's Table 1, it'll give you the equipment or a task. So for example, it says stationary masonry saws. So we know that's a saw used to cut the CMUs or blocks or bricks. Then it gives you the control method. So the control method for this is use a saw equipped with integrated water delivery system that continuously feeds water to the blade. So the key part there was what? Integrated, right? Mm-hmm. So it's a system that has a integrated water system, not my fellow coworker standing behind me spraying a hose. So it's integrated.
So I can't throw water balloons at the saw while you're cutting it?
No, it ain't going to work. And then the other part of the control method is operate and maintain tool in accordance with manufacturer's instructions to minimize dust. So basically you have to use the tool as it was designed by the manufacturer, and you have to use it with an integrated water delivery system. If you do this, you do not have to have respiratory protection. So that's how Table 1 works. It lists those three things: the equipment or task, so stationary masonry saw, the control method, so integrated water, and then the required respiratory protection. For this 4-hour shift, none. More than 4-hour shift, none. So I'm going to go down and give you an example of one that you would actually need a respirator with. And it's going to be for, if I can remember right, it's going to be grinding concrete. So so the equipment or task is handheld grinders for mortar removal. So, we're using grinders to finish concrete. We're tuck pointing. We're basically getting a final product on our concrete. The control method for that is you have to use a grinder with a commercially available shroud and dust collection system. So what's that mean? Does that mean I can go put a shop vac on the end of my vacuum? No, you got to go get something from a manufacturer that's commercially available. Obviously, we got to maintain and operate the tool based on what the manufacturer says. And then also a dust collector must provide 25 cubic feet per minute, so CFM, or greater airflow per inch of wheel diameter, blah, 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 blah. So these are all things you are on OSHA's Table 1.
Now, and I talked about this in part 1 of this series. But we're Dylan, where you just mentioned about that it must provide 25 CFM, cubic feet per minute or greater when it's collecting the dust.
Mm-hmm.
this is where it is required to have something that is in this vacuum that is either a reverse flow, or I'm going to change out the filter manually, clean it out.
A
whatever
filter
the case.
cleaning
Right.
mechanism, yeah.
So because once you get below that 25 CFM, then OSHA says, okay, well, you are no longer following table 1.
Right. And this is the easiest way to be in compliance. So the equipment and task was handheld grinders. The control method was commercially available vacuum. But there is still respiratory protection required. So if you're doing this for less than a 4-hour shift, you still have to use a respirator with an APF of 10, so an assigned protection factor of 10. If you're going to do this more than 4 hours, then you have to use a respirator with an APF of 25. So, right there, even though you're using this commercially available shroud vacuum system to eliminate dust, you are still required by Table 1 to wear a respirator. So there's a couple tasks on here that are like that, but there's 18 tasks on Table 1, and each one gives you specific guidelines on how to be in compliance and how to protect your workers.
Yeah, and Dylan, I'm not sure if you mentioned this at the beginning of this, or maybe I should have. So this Table 1 only applies to the construction industry.
Right.
It does not apply to the general industry. It does not apply to maritime. This only is an option for the construction industry, period. And so basically what it comes down to is that when you're talking about Table 1, though, there are 2 methods to limit the exposure, and that's the wet method or the vacuum method.
Mm-hmm.
It's just so to make it cut and dry is that you're either going to use an integrated water system, or you got to have a vacuum system, that's sucking up the dust, collecting the dust while you're working.
Yeah, and I mentioned integrated water system a minute ago there. Something that's I've noticed or observed on sites while I'm walking around is people will be saw cutting, using a gasoline-powered cutoff saw to break through asphalt concrete. Pretty normal construction activity for road work. And for their compliance, for their silica exposure, they take a 5-gallon bucket of water and drill some holes in it. So as they're saw cutting, they have a bucket sitting next to them letting water run. So is that an integrated water delivery system?
Negative.
No.
That's some back alley engineering.
Right.
Is what that is.
So that doesn't follow Table 1. That doesn't meet Table 1's requirements. So we talked about different options for being in compliance with standard. Obviously, Table 1 is a good one. And like Junior said, it's only for construction, though. Another way we can do it is to do our due diligence and do our testing and know what the exposures are. So for that specific example I just said, where this employee was using a bucket of water, is that under the action level? Is that sufficient enough? I don't know. They have to provide the testing. They have to have that employee do that task wearing a cyclone dust monitor to see if that employee was above the action level.
Yeah. But when we're talking about this method here, we have to make sure that it is per the task. And so if any conditions change, so let's just say if we're out on a concrete slab doing this work, so we're using the saw and we're cutting, we're using the mason saw, and then we're cutting through the slab, and we might have tested and everything came out good. But let's take that same employee with that same saw, and then now he's inside. Maybe he's inside the basement of a building,
right?
And he's cutting.
Makes
down.
a big difference.
It does make the airflow. You don't have that natural airflow anymore, and now he's in a room that might be 10 by 10 by 10 or something like that. And now the exposure level has changed because the environment has changed, the conditions changed. So the method that Dylan's talking about now, we're going to have to do some testing all over again. Mm-hmm. It's not going to apply in every scenario. So if any conditions change, we got to test again.
And I think that's where employers are having a difficulty with this standard is if they do the testing, have an industrial hygienist come out and do this type of testing, they're assuming they're good. We had a guy drill some holes in concrete and we tested and he's fine. what if the conditions change? What if you change drills? What if, the size of the drill bit matters, right?
Right.
A 1/4 inch and a 1/2 inch drill bit, or one's creating more dust than the other.
Right. Yep. So just talking about the vacuum and the wet method again. So in the vacuums, you got to have a HEPA filter. It's got to have the 25 CFM. It's got to have a mechanism in there that's going to be able to unclog the filter if it's getting clogged up. Or your procedure has to be to periodically replace that filter. And then when it comes to the wet method, it's got to be an integrated water system that's tied into the tool, not tied to the tool. Mm-hmm. That's tied into the tool by the manufacturer. It can't be a water hose. It can't be a squirt gun. It can't be water balloons. It can't be anything like that. It has to be something integrated, by the manufacturer.
And just so everyone's aware, the reason for the whole water method having to be integrated is me spraying a hose doesn't eliminate the silica dust particles, because the water droplets are larger than the silica particles. Mm-hmm. So whenever you see, I'll use a demolition site, for example. You have a bunch of excavators, crane, wrecking ball, this kind of stuff, tearing down a building. You see this giant dust cloud. How do they eliminate silica? They have commercial misters everywhere. So these misters are creating these water droplets that are the same size as the silica particles. So what happens is the silica particles and the water droplets attach, and then the water knocks it to the ground. Mm-hmm. If you use a hose or another type of water delivery system, the water particles are too large and they don't collect the silica particles, and therefore they just bounce around and stay in the air. So they have to be small, like a commercial mister.
Yep. Good stuff, Dylan. Let's talk about the, we talked about the integrated when it comes to the water system that's in there. Mm-hmm. How about the integration of, tool adapters?
Yeah.
That have come out now.
So I'm convinced that Hilti and Milwaukee and Bosch and all these equipment manufacturers, they were all in cahoots with OSHA with this new standard, because they got rich. I know these HEPA vacuums are not cheap. They're like $5-10 grand a piece. I know on my site we bought like 10 of them. We spent like $100,000 just in vacuums.
Yeah, and then on top of that, when all this first rolled out, there was a backlog of waiting.
Oh yeah,
you had to pre-order some of these tools and stuff like that, and then you were on the waiting list.
Everybody waited till the last minute to be in compliance, right? We knew about this silica rule for a while, and everybody was hoping that it was either just gonna keep getting delayed or get nixed. And whenever they finally put it into effect, everybody's like, "Oh man, we better hurry up and go get the tools to be in compliance." So, like I was saying, all those tool manufacturers, shout out Hilti, Milwaukee, DeWalt, Bosch, hey, if you guys want to sponsor us, we're all about it.
Yeah.
But anyways, they're making all kinds of tools. They're making the HEPA vacuums, and they're making tool attachments. So a perfect example of this is drill bits. I know Hilti, and I'm assuming the other ones do as well, but Hilti makes hollow drill bits now. So as you're drilling, there's holes in the tip of the bit that allow the dust to come through the bit itself, and then it has a HEPA vacuum attached to it. So they have these vacuum attachments. They have these drill bits that are hollow. They have all kinds of commercially available dust collection systems, just like OSHA says.
which was pretty neat about the hollow drill bits, because Lieutenant Oates, I don't know if you could think of this offhand, but when we used to have to put anchor bolts, and we'd have to drill the hole to drop an anchor bolt.
Oh yeah, and you keep and down.
Yeah, but how would you get the dust out of the hole?
You blow it out.
You blow it out. Yeah, you get your air hose straight from the air compressor and then dust is everywhere.
So to be honest with you, we had the Hilti rep out and we were doing some stuff with it. You can actually drill holes so much faster with these new bits, because it doesn't have that buildup of the dust and stuff in the hole. You don't have to blow it out. It'll just drill right through it so much smoother, so much faster.
It's fancy stuff.
Yeah.
So again, if you're listening, DeWalt or Milwaukee, whoever, send us a tool and we'll put it up on one of our on one of our videos here.
And then something else is maintaining these types of tools and attachments. So you can't connect them with duct tape. You can't have broken hoses. You got to use the tool as it was designed from the manufacturer. You can't, rig up your own thing. I'm sure you've seen some crazy things in your day.
Yeah.
How people make tools work. That doesn't work for this type of system, because as soon as you alter the tool or equipment, it's no longer working as efficiently as it should be.
Yep. Okay, so we had talked about in the in part one of this series, one of the things that we talked about was an exposure control plan as one of the requirements now. So when it comes to this new standard, it's required for the employer to develop and implement this written plan and that's what we're talking about in the last part of this, or the first part of this, is that there's got to be a competent person that is designated to this job to implement this plan and so forth. But it's this plan is going to break down the specific workplace activities that's going on that involves the silica. Provide the method of how we're going to reduce it. So provide a method of some of the things that we just talked about. And it's also talks about the engineering controls, the work practices, housekeeping. Again, so all of that stuff that we were just referring to, that all has to be a part of this plan. It can't just be hey, Lieutenant Oates, we're going to have you go out there and cut this concrete up. Make sure you don't create no dust. We have a vacuum. Use it when you can. It has to be a procedure that is written out, that is followed, implemented, all of that good stuff.
Step by step.
Even if you're doing everything the right way, it's still a requirement to have a written plan on site showing that, hey, these are my exposures and these are my controls. This is how I've been exposed to silica, and this is how I'm going to protect my workers.
Mm-hmm.
Yep. So Lieutenant Oates, give us some of those. Just run down and just talk about what does the plan have to include, just step by step.
Okay. First of all, it has to include the description of a workplace task involving exposures to respirable.
I know that's a difficult word, man. I tried hard.
Silica, right? The plan must include a description of engineering controls, work practices, and respiratory protection used to limit employee exposure to respirable crystalline silica for each task. Then the plan must include a description of housekeeping methods used to limit the employee exposure and respirable crystalline
Hey,
silica.
one of these times you're going to nail it.
Get it one time. Excuse me. And then the plan must include a description of the procedures used to restrict access to the work areas when necessary to limit the number of employees exposed to the respirable crystalline silica and to the levels which they're exposed, including exposures generated by other employees or self-employed workers.
So right there, that last one's a big one. So, for example, I'm going to use concrete finishers as my example, because that's the one I can most likely I'm most familiar with. Basically, though, you have these concrete finishers grinding concrete to finish it. So they have their grinders. They have their commercially available shrouds and HEPA vacuums to eliminate the dust. They're wearing full face respirators because they're working longer than a 4-hour shift. So those are all three of those right there were part of table one. So that's how they're working. As they're grinding the concrete and they slightly adjust the angle of that grinder, or they tilt it just slightly, a dust cloud comes out of that vacuum because it can't catch everything, right? So what happens to the other workers around that worker? So say I'm an electrician working in a panel, 15 feet away from this guy's grinding concrete. He's now exposed, right?
Yep.
He's not doing the task. He's not required to wear the respirator, but he's exposed. So how do you fix that? So something we've personally done in the past is we've created, silica controlled zones. So if the concrete finishers are working in a zone, we basically barricade that area and hang signs saying, hey, this is a restricted access zone. There's silica present. You can't go in here. You can't work here. So it goes back to pre-planning that work,
Mm-hmm. That's like I said, that pre-planning. That's the most, to me, the most important thing of a job. You know what I mean? You got to make sure that the people are going to be all right. That's out there in those areas working.
Right. You don't want to schedule two people in the same area at the same time if you know that one's going to expose the other to a hazard.
Right.
Yep. And I want to bring up some unique scenarios. So, some of these older buildings, the way that they're, mechanical ventilation systems, are set up is, and I've seen this, you could have some renovation work going on in one part of a building, maybe on a lower floor or an upper level. And there's a return system for the unit, and they can actually have that dust going into the system now, and now that silica is being distributed to the rest of the building.
Yeah.
Because I've received calls like that. So, we got dust coming out of the air condition, thinking the air condition's on fire or something like that. And it's just that the way that older building was set up, the return system was just blowing the silica dust right back into the rest of the building. So, when we talked about this exposure control plan, we talked about the description of engineering controls. So that is a part of that engineering controls that you have to make sure that there's no way that this exposure is going to happen to your office workers. To personnel or individuals that's in another part of the work site. Maybe it's a windy day and they're downwind from the work that's going on or something like that. So when you're talking about your controls, whether it's engineer mount or administrative controls, you have to make sure that everyone's protected, all around. But with that being said, there is an option 3. So, we talked about creating your own plan. We talked about table 1 for the construction worker. So, what's option 3? What's the next option?
The worst option available. This is for your workers, it's miserable. But the option is to have everyone wear full face respirators anytime they're exposed.
Yeah, and we talked about this in all of our podcasts. There's engineering controls, there's administrative controls, and we could put training in place. And the last line of defense is always going to be, well, we're just going to throw our employees in PPE. We're just going to throw them in half-mask respirators and full face, fresh air. We're just going to not spend the money on trying to, figure out how to engineer these controls out. And that is it's sad to say, but that is option 3. That is an option.
But remember, if you go with that option, you enter the medical surveillance programs, right? And that's when you have to meet all those types of requirements. So it's not cost effective, in my personal opinion.
Yeah, so we're still going to have to do you're still going to have to do the fit test. You're still going to have to, do the quantitative, the qualitative test, make sure that they're fit for duty, still go through, the licensed healthcare professional, all of that jazz, just because we want to default back to option 3. So
yeah, and it's a lot of work and a lot of money, so it's not always going to be your best option. Most of the time, it's not going to be your best option.
Right. And I would just, as we're wrapping this up, I would just advise everybody out there, look into your organization and look at some of the unique things that you deal with, because you might not even realize it, but you could be exposing your organization to tasks that involve silica, and you not even realize it.
Yeah, so some of the simple things I've seen on construction sites or any other workplace is, anytime you go to mix a bag of concrete, mortar, stuff like that, when you're dumping that bag into a bucket or into a hopper, you're creating a dust cloud, right? You may think like, oh, I'm mixing it with water. Oh, there's no dust, right? But that initial mixing, the initial dump, that's when they create that dust cloud. So they do make certain things out there. I've seen, it's called a whale tail. It goes on the top of a bucket. It literally looks just like a whale tail, and it attaches to a vacuum. And so as you're dumping into a bucket, it's sucking all that extra dust out of the air. So there are options. Maybe you do put your employees in respirators for that portion of the mixing process when they initially dump something in and you see that dust cloud. Maybe at that point we have the workers protected. Maybe we need to restrict worker access to that area. So if we have an area, a lot of times on sites you see brick masons have a setup where, hey, we're doing all of our mortar mix in here. Maybe that's a restricted zone for only the certain workers, and it's a silica controlled zone, and to be in that zone you have to have a respirator, or maybe we create a barricade, we create a tent over that to so that exposure isn't getting to the rest of the job site if you have a tight job site. So there's a lot of different options, and you just think about all the different places and job activities that are exposing employees, and make sure we're doing something to eliminate that exposure.
Yeah, and you might even be an organization that's not on the, I guess, in the major spotlights. Maybe you're not an organization that's involved in demolition of a building or a stadium or something like that, or maybe you're not in a company that's creating CMUs or bricks or paver stones or a concrete batch plant or something like that. Maybe you're a smaller residential organization that's just maybe laying tile down and you got to mix grout and that your employees are doing that every single day because y'all are building a whole new subdivision or something like that. So
even if you're self-employed and you're just doing tile work on the side, you're still exposing yourself. You're causing that harm to yourself by not protecting yourself. So no matter what the situation, if you're creating the silica, try to figure out a way to reduce it or eliminate it.
Yeah, because like we talked about in part one of this series, is that once that scar tissue sets in, once you have that silicosis,
there forever.
It's it. It's like bad luggage. It's going to follow you everywhere you go.
Yeah. That was a good scenario. Or, you know what I'm saying.
Yeah.
You know.
So, okay, we talked about the new standard. We talk about, what is silica, the new rule, the employee requirements, the exposure control plans, medical surveillance programs. If you're in construction, we talked about table 1, the different methods of the integrated wet method systems, the vacuum systems, the tool adaptions that are out there. So just go back, listen through it. If you're a company that is involved with silica, the exposure to silica, I would just urge you just to go back, listen to it a couple times, take notes. If you ever have any questions about this or any of our other podcasts or videos, you can reach out to us at hardhatuncovered@gmail.com, all one word.
Or you can even look us up on LinkedIn. I know I've had some people look me up on LinkedIn or message me. I check it often, so if you have a question, especially about this silica stuff, shoot me a private message, shoot me a public message, doesn't matter. I'll more than likely get back to you with an answer if I have it.
Yeah. And so, there's other platforms out there. So, we're on all the podcast platforms. So you can reach out to us on Anchor. Just reach out to us however you can. Again, if we get enough followers, we talked about we're going to give Lieutenant Oates' personal number out. That way you have to reach out to him directly. But again, we're on all the podcasts, Pocket Cast, Radio Cast, Google Cast, Spotify, Apple Cast. Be sure to like this video, like this podcast. If it was something you enjoyed. Reach out to us if there's something you want us to talk about. Make sure you're hitting that subscribe button. Turn on all your notifications. That way you can hear the message fresh as we put it out on the interweb out there. YouTube, Facebook, LinkedIn, all of it. Just follow us on all of that stuff. So, and Dylan, why don't you go ahead and just remind everybody of the mission out there.
All right, guys. Remember, making a change impacts me, making a difference impacts others, and making history impacts the world.
All right, remember, we are coming to you from the HardHat Uncovered Studios in Alexandria, Virginia. And thank you for taking the time out of your day to listen to us. And until next time, Lieutenant Oates, Mr. Hipple.
All right, guys. Catch you next time.
All right, y'all be safe out there.